So for this week, we'll start with forced air system. Quiet, please. If you have any questions regarding hydronic system, please come see me in office hour after class. I will help you out. But so far we did hydronic, hot water and steam. And for hydronic, we did piping layout, heat load estimation, radiator estimation, pump sizing, and thermal expansion duct, which is the major components you need to work and to size with a hydraulic system. We also did steam last week, and again, I highly doubt you will be putting new steam systems, but you will be encounter some of them in the field as a repair, so we got exposed to that a little bit. This week, I would like to talk about forced air. Forced hot air becoming very popular because they can be coupled with air conditioning. So a lot of people now are thinking, if I'm going to put a new system, I'll put forced hot air. And heat pumps are becoming very popular. They do hot air, cold air, so they're dual system. So we'll talk about sizing large systems for air conditioning. By large system, we talk about central air. We're not talking about mini splits, about duct system, what are the variables, and what are the differences between a system that's designed to deliver hot air and a system that's designed to deliver cold air, and both. It's not the same. So a system that is designed to only work for AC might not work very well with hot air. So we will try to see what are the differences. So the first thing we need to know is how to measure air quantity. So the difference between hydronic and forced air is that in hydronic system we are heating the air inside the room. In forced air we're taking the air outside the room, heating it, or cooling it, and bringing it back. So we take the entire air, there's a lot of suction of air, cooling and conditioning the air, then bringing it back. That is a big difference between hydronic system, where you deliver the heat from the source all the way to the room. In this case, no, we're taking some air, heating it or cooling it, adding moisture, taking moisture, then putting it back. So how do we convert BTU to CFM? So I want to know in the project, since you have BTUs for every room, how much CFM is that? What is CFM? Cubic feet per minute. I'll write it down. It's a measurement of quantity, so it's cubic feet, it could be gallon, it could be something else, but it's mainly volume, because we are treating air as volume. We're taking volume out and putting volume in. So how do we convert that to BTU? From BTU requirement to CFM, and how do we deliver that and distribute it to the room in an even manner? Describe the common types of motors and drive assemblies. That's really easy, because this is going to be the equivalent of a pump. You'll have to move the air from the room and to the room. One big issue that happens with duct that we do not have a lot with hydronic is the noise. So you can hear the noise now, the air pumping, even though from the mini split, you can hear it. It can be very loud, and we don't notice it sometimes, but I will show you how can you measure the amount of decibels of that system, and what is considered to be loud and what is considered to be quiet. And the noise coming from duct work and air is related to migraines and discomfort, so we want to minimize the amount of noise. Various duct system. What kind of ducts do we have? What kind of we have either return and supply. Sometimes we have fixed duct. What do we have? Aluminum, GI, galvanized steel, galvanized aluminum. We also have flexible duct, which look like hoses. We have high velocity duct. There's so many possibilities to deliver air to the room. They all have advantages and disadvantages, and they all can be suitable for one application but not the other. So we will talk about different aspects. And finally, noise control. Air can be very, very noisy if it's too fast. And if we were to think about what we talked about, which is the flow rate. Flow rate is in GPM, it's in volume, so it's volume. What is the flow rate? Velocity times area. So if we want to maintain the same flow rate, you would decide that this room requires 300 CFM or 30 CFM. I want to maintain that flow rate. I can control either the velocity and or the area. So either you will have bigger register or slower velocity. If you have the flow rate with smaller, with high velocity, which is means also small area, what will happen? It will be noisy, and it will throw very far. It will disrupt the flow of air inside the room. Nobody wants a drafty room. You don't want to be having an area of the room with air blowing one side, and the other side is very quiet. So we want to have balanced air distribution. So we'll talk about noise control in terms of flow rate and how do we change the area to maintain the flow rate. Usually the velocity is difficult, it's more difficult to control, but it is possible to lower the velocity if you have very small area. But at the end you want to control the same flow rate, volume, which is CFM. You want to keep this constant. Why? Because that's the BTU you need. I need this amount of CFM. So I have to play with two things, either the velocity or the area. So air has to be conditioned in most cases to be comfortable, either for heating and cooling. We will change the temperature. Either we increase the temperature or decrease the temperature. We can also do particle removal. Since we're taking the air from the room, we can have the advantage of taking out particle, dust, sometimes animal hairs, sometimes whatever you have, pollens. You can condition that, you can remove all those particles using a filter. And that's something a lot of people like about forced areas. We can filter the air while we are recycling. We can also do moisture control. Most of the time when the air is hot, it gets very, very dry. So maybe we can add the proper amount of moisture into the system. One last thing is we can do ionization. This is a new feature, a new fad to ionize the air to make it more comfortable. And make it also attract more particles when sticking to the filter. So equipment include cooling coil, heating device, device to add humidity, or a device to clean the air, mainly a filter. Filters have to be changed frequently or cleaned. Some filters you can change, and some filters you can clean them, vacuum, or even wash them. Humidity, what do we do for humidity? You're gonna do two things. In the summertime, you're gonna have a condensate pump. Find a place where you collect all the condensate, usually at the heat exchanger or the air handling unit. Usually see a small drip pan, a hose, and a condensation pump that will take the water to the outside. In the winter time, you want to add humidity. So you'll have water supply, big mainframe that will be moisture at the air outlet where you add humidity to the air. Forced air systems use the same room air over and over again. So at some point you will need to introduce new air. If you look at your car has a forced hot air system or cold air system. There's drain. If you turn on your AC in the summertime, you'll see it dripping under the hood. There's a lot of water. You see a big puddle of water. All the water goes outside. So steam will find the air. In the winter time, it's there, get drier, and there is no added moisture. What happens if you have, why do you have a vent in your AC in the car? So you can bring in outside air. Most ACs have a small vent where you can mix up existing air with incoming air. In the winter time, there will be very cold incoming air. In the summertime, it will be very hot incoming air. That's why when you put your AC or max AC, what does it do automatically? It will close the vent. So we will recycle the air inside the car to give it maximum cold temperature. So again, fresh air enters the structure by infiltration or by mechanical means. Mechanical means we mean forced ventilation or inducer fan, and sometimes by infiltration. If you have a lot of infiltration from the windows and doors, probably your system will be exchanging air naturally. But ideally, we want the structure to be almost airtight, and we want to produce our own ventilation. Why? It's better to have controlled air coming into your house, especially this season now. We have pollens all over the place, allergies. You want to introduce air that is free of pollen. You need some kind of filters. HEPA filters came, I think, in the early 2000s. How do filters work? You basically have different pressure from one side to another, and you have small openings, small porous material that will capture all the particles. If you use something called reverse osmosis to purify water, what does it do? It pushes water through a filter, and the salt particles in the water are bigger than the water particles. So there's filters small enough that it will capture the salt molecule. So this is how reverse osmosis works, and this is how most filter works. We don't see those particles, but they are there, and they get captured in your sinuses sometimes, or your lungs. So we better capture those particles before they get into the house. So this is what a forced air system looks like. We have an air handler unit. Sometimes it's coupled with a furnace, and sometimes has an air exchanger. Usually we have an air damper from the outside. If the system doesn't, maybe we should make one. And you can see this is the air being sent, coming up from the living space, going through the air handling unit and going outside. It's the return air. So usually you want the damper to come with the return air, because this is the direction of the flow. So what is the pressure here? Is it lower or higher than over here? It's going to be low pressure. It will pull in things with it. Same with the flue pipe in oil burner. Remember that the swinging door, as the flow goes out, when air have high velocity, it has also low pressure. When you open your window in the car, you cut the window. Does the air come in or out? Are you sure? It comes out. If you cut the window in the car, close all the windows. Crack the window open and hold a piece of tissue. You'll see the air coming out. If you don't crack another window or the vent, you'll hear a suction vacuum. It hurts your ears sometimes. I don't know if you noticed that. And you hear what's kind of wobbling vibration inside the carpet. That's the vacuum. That little hole is trying to pull in air, but there's nothing coming out. So either you have to open your AC vent, or you have to crack another window to release the pressure. So fast air from the outside produces vacuum. It's pulling things out. So if the airflow here is circulating, it's going faster, so it has higher pressure than the air outside. If you have a windy day, this should close. The faster air will have more suction. If you have a very fast wind outside, probably it will go back on the damper. Any question? Does this make sense? Make up air to the system, circulating the air, and adding new air to the system. So we need the correct air quantity. And we want that in a very good rate, where we can change the air quickly, not too fast and not too slow. And the air quantity depends on how much we can heat the air. So we're taking air from the room, taking it to the air handling unit, we're heating it, sometimes up to 110, 120 degrees, 160 degrees, depending on what kind of furnace do you have, what kind of apparatus do you have. So we need the right amount of quantity of air. Different spaces require different air quantities based on the BTU, and they're equated for the BTU. If you look at the calculation sheet, and the radiator selection, the equation here, it says CFM equal BTU over 1.08 over BT. So I will write that down. this is the air quantity you need to deliver to each room to maintain temperature. So what is the BTU here? Heat requirement. Yeah.
Is the CFM going to be the same for both heating and cooling?
Yeah, but well, the change is going to be the delta T. And the
Oh,
BTU
okay.
for cooling and the BTU for cooling.
Okay, yeah.
108 is constant. And it's the, what is 108? Heat capacity of air. So this is going to be constant. Delta T, temperature difference between 101. Air in the room and air in the furnace. So what am I pulling out? What is the temperature over there? 50 and 60. And the temperature coming in, 120, 110, and so on. So different spaces require different air quantities. That's because different spaces require different heating loads. Same structure may have several different cooling requirements or heating requirements. What is that based on? Based on your BTU, amount of windows, how much leakage do you have? So for example, if you look at this layout, different CFM for each room, and this is the conversion. So if you look at the cooling, we need 9,000 BTU for cooling and 18,000 BTU for heating. And why is that? That depends a lot on the location. And if you did the project, the cooling load, probably you have noticed that the cooling load is very low compared to the heating load if your house is in the northeast. Because in the summertime, it doesn't get that hot for that long. Meanwhile, the BTU, we turn on the heater in December all the way to June. And it gets really cold. But that's why, that's why the heating load is much higher than the cooling load. So when we design the CFM, we want to use the BTU for both heating and cooling. Which one do we size? For what size? The cooling or heating?
Where you want to do what?
If you want to size the amount of CFM required for this room, I'm not going to use the heating or cooling? Heating. Heating, why? It's higher. Good. Okay. Yeah, sure. So we will size for the heating and the cooling because it's higher, and you can always step down instead of going up. What happens if I size for the cooling?
You're not going to get the proper heating?
You can, but you're gonna have to pump up the velocity, right? It's gonna be very high velocity, and that will lead to what? Noise, discomfort, and high draft. So you don't want to have that. So that's very simple concept to have. Forced air system component that make up the system. We have an air blower, which is equivalent to the pump. Air supply system and return system. So this is going to be duct. Grills and registers. This is what we see over here. These are the grills and registers. These are equivalent to your radiator for heat. So this is how you dispense the air. The bigger the register, the smaller the velocity. Big area, small velocity. Slower air means quieter, less draft, less flow. Do we always want less flow? Not necessarily, depending how many of those do you have. If I turn off this mini split, probably you cannot hear the air here at all. Why? Because we have 1, 2, 3, 4, 5 registers. So the flow is very slow and it falls quietly. We have 2 intakes here. Those are the intakes. This is the back. Those are the 2 intakes. If you also notice, there's one intake in the top. Huh? These ones. Here. If you notice something, where do you usually put the filters? The intakes. top, so that's cooling and heating. So when I want to, that's it. When I want to do hot air, I'm going to switch the supply to this one, so I can pull all the cold air. In the summertime, when I want to pull hot air, I'm gonna pull from the top, it's all the hot air going to top.
That's
So,
it.
huh?
You're doing like a new install on the house though, would you put two returns in, one in the floor, and one in the ceiling, or?
Ideally, yes,
Yeah.
but it's not always the case.
Yeah,
It's not always the case.
cause then you're,
Yeah.
yeah.
It becomes a struggle when you have the cold air coming from the bottom. It's gonna take a while for to build up enough cold air, so it takes longer. So this is actually, ideally, you want the return and supply, the return to have two returns, one for the hot and one for the cold, to have more even distribution, and you don't have to pump in air like crazy inside the house. But people try to minimize duct cost because the cost of duct is high, installation, design, and they have to be sometimes made in a warehouse and brought to the place and assembled in there, so it costs a lot of money.
Yeah.
Occupants should not be aware of the system on and off. This is ideally, you want the system to be as quiet as possible, and you just feel the temperature, and you don't feel the air coming throughout. So these are supplies and these are returns coming into the air handling unit. And if you notice, this is probably for cold air. So the blower motor provides pressure difference to force the air, move the air from one region to another. Typically, we have 400 CFM of air must be moved per minute per ton of refrigeration. So for ton, that's 1200 BTUs. We want 400 CFM to move that around. Then you can go and open dampers. You can easily use the damper motors to open and close the damper for one room. That's how we do zoning. Or you can use different air velocity, high velocity, low velocity. What happens if you have a damper, a blower motor that's high velocity, that is designed for all dampers to be open? What happens if you close two dampers and the velocity is still the same?
I don't know, it's gonna hit pretty hard.
Yes, and it's going to be very noisy. Probably you have noticed if you close all the vents in your car and you have only one open and you crank up the speed, it's going to be very noisy. It's going to shoot really high, but it's not very pleasant. So pressure in ductwork is measured in inches per of water. It's called the water gauge. It's how we measure the pressure inside the duct. I don't know if you did that with Bill, probably did last semester when we did like principle of refrigeration, where you want to measure the velocity of air because you want to make sure the air is flowing the right way. So we measure the velocity of the air inside the duct using a manometer. The other way to measure it is using the hood. You use the hood. You cover one of the register and calculate the CFM. There are two ways. Either you use the hood or use the velocity using that little fan that will give you the airflow, or you can use a manometer. Where do we use the manometer? So you can use the manometer when you don't have access to the airflow. You're outside. You want to measure the pressure in the duct outside. You have no access to the airflow. You can't stick a fan in there. You can't stick a flow gauge in there. So you go using the pressure, and there's a calculation for that, which I'm not going to get into. But if you work for a company that installed duct system or ACs, probably you have to know how that's done. This is the fan and the venturi. The fan provide a lot of pressure and push the air into the venturi. Squirrel cage, your centrifugal fan, probably you have seen those inside the duct. They are good for duct work and they're designed to be inside the duct, so you take the fan outside completely with the box and you can put it inside and use the squirrel gauge. Build more pressure into the outlet. Forward curved blades, looks like actually looks like that. This is the same fan, but in a bigger scale. So it doesn't have blades, just have cage and I don't know why they call it a squirrel gauge. I think they were thinking of hamster wheel. Somehow it became a squirrel for some reason. But it's called squirrel cage using vent. They are very quiet when properly applied at the right speed compared to the propeller. Yeah.
What do you think happens when a squirrel gets inside that tank, finds the way and gets in there?
He runs on the wheel.
Yeah. How the time? You play with it for a while.
They're a lot bigger inside of a building.
Yeah. Actually, somebody sent me a picture of a squirrel trapped in a squirrel cage. I don't know if you have seen it. So they have, they can be used for very high pressure because again of the induction it has. You have the same kind of inducing fan inside your car. If you look at your AC, it has one of these, sometimes upward and sideways, and it pushes the air. Because if we're talking about physics, the amount of air you're pushing depends on the blade size and the curvature. And here we can combine a lot of blade sizes in small increments and provide more pressure. So it looks like it's bigger, and this is how it moves the air into your blower. This is the housing. I don't know if you did the lab where you have to take the motor out. It's very, very painful.
Mini split?
Yeah. Many splits are also in central air system. Taking this out is very challenging. But these fans actually do go bad. If anything goes bad, it's the fan, or sometimes the bearing. It's better sometimes to have the motor not attached to the wheel, makes things easier. I'll show you why. You have a belt drive. So you keep the motor far away from the fan, so the change will be easier instead of taking the fan with the motor outside. So the belt drive will give you more flexibility in changing the speed and more flexibility to changing components inside the motor. We have a motor with pulleys, and the fan has one side of the pulley, and the motor has the other. I'll show you a picture. So direct drive, it means the motor is directly connected to the fan. Belt drive, it's indirect, which means that there's a pulley system and there's a belt connecting the two pulleys together. Speed can be changed by changing the motor wire leads. So there are some variable speed motors now where you can change it high and low, and sometimes you have 3 settings. That's why you have more than one wire: low, medium, and high. If you look in here, we have 3 speeds for the motor, and you have control for the fan. And we have, this is just on and off, but some of them have low, medium, and high. These ones in the mini split, they have different speeds.
Can you modulate the voltage some of those and get
No,
it to go?
no. If it's not designed for that, you cannot do that. Yeah. It's not going to work as well. So this is the blower motor, this is the belt drive. We have the motor with the pulley, the belt. This pulley will hardly ever break. All you have here is bearing and pulley. And sometimes you might have to go and clean it, but you don't have to take it out. Taking out the squirrel cage out of the duct is a very big work. That's why they put the motor outside and they use a belt drive to turn on the fan. The assembly. So, supply duct system. These are the different types of ducts we have. And it's good to know and recognize what kind of duct system you have. The first one is the plenum system. What's a plenum?
Little lip.
It's a very big duct with branches coming out of it. There's something called an extended plenum system. We have one duct for the supply and one duct for the return. And we have a reducing plenum where the plenum started off really big and it keeps going smaller and smaller and smaller as we go along. And why do we think we're doing that?
Maintain pressure.
Maintain pressure and flow rate. We're changing the area and keeping the velocity the same. So area will change in the air. Again, what is the difference between air and water when it comes to pumping? Compression. Air will compress and air will make more noise. And air, as any fluid, when you pump them faster, they will start to produce turbulence and vortices. So since air is moving way much faster than water, it is more prone to turbulence. There's also something called the perimeter loop, where we go around the room, and you have perimeter, where we supply many sides of the room, all around the house, all around the room, unlike this one, the top. So the plenum system is suited for jobs where the room outlets are all close to the unit. Supply diffusers are normally located in the inside wall, and it's better work with fossil fuel systems. Why? Somebody tell me why. What makes fossil fuel better for this AC, for this hot air?
Energy dense?
And what else? So what does that mean? It's gonna give you a lot of heat. The hot air will be around 180. It's very, very hot air. So by the time you send the air all the way to the rooms, you still have some heat. It does not lose heat. Meanwhile, if you use, what is the alternative to fossil fuel?
Renewable?
Or what else?
Gas?
Still fossil.
Natural?
Electric, you can have it, if you have electrical heaters, or you have heat pump, it's not going to be as hot as fossil fuel burning. So it's going to be lower. It's hot enough for you to achieve the room temperature, but it's not hot enough to go for distance. So we can easily have 130 coming out of the air handling unit, but usually for mini splits, not mini splits, for central airs, you cannot get this high, maybe 100, 110, 90, which is enough. What is the required room temperature? 75. So if you supply air within 85 and 95, you can reach that temperature. And again, with forced air, you're exchanging air. So you don't have to heat the existing air. So you're taking the air, you're heating it up and supplying it back 85 to 90 to blend with whatever is existing in the room. This is the plenum system. So you have one long plenum, and we take branches out of it. This is flexible duct. So as we said, all the rooms and all the supply are very close to the plenum. This is the regular plenum, and flexible ducts are okay as long as they're not too long. You don't want to be too long because they're very flexible. They have a lot of ridges, and it will slow down the air and will make a lot of noise. Okay, I'll stop here and I'll continue next week.